Right, so good morning, everybody. Thanks, Prashant, for the invitation to come and talk today. So I'm going to talk about one aspect, I guess, of relevance to Reclaim, which is around air quality and perhaps what the opportunities and challenges are for that in the UK. So I start generally with a slide with almost no words on it, and it's just to remind everybody that air pollution as a problem is not fixed. The pollutants that we deal with actually change over time, and the sources that we deal with change over time. And this is one of the really key issues that differentiates air quality interventions, say, from climate change. You know, the key drivers associated with climate change 100 years ago was carbon dioxide arising from burning fossil fuels, and it's exactly the same problem and pollutant today. It's not the same in air pollution. The problems that we dealt with, say, 70 years ago were associated with large particles, sulfur dioxide, and so on. Then we dealt with problems associated with acid rain, then we've dealt with problems associated with nitrogen dioxide, diesel engines, and so on. So the problem changes. So we have to be much more flexible in our thinking about how we deal with interventions that we aim to use to improve air quality. And this is one of the really big challenges, because the things that worked 10 years ago or 20 years ago might not work today. And that's quite a hard thing, because that's hard for us to accept as scientists, that our good ideas might have an end date to them. And it's really quite hard for policymakers and politicians to understand that what was a good idea 15 years ago might have changed. So I just say this at the start, because we're going to go into a world, hopefully a net zero world, where we will probably end up inventing new sources of air pollution that we're going to need to help to manage. Now, there has been a lot of success in reducing emissions of air pollution, and it's actually worth talking about some of the successes, because I think that's often rather motivating to get people on side. There has been tremendous progress, often in the things related to combustion. So these are the predictions essentially of the emissions sort of back into the 1800s, when we didn't really have good emissions inventories, the period when there's very good statistics, and then some estimates of the likely trajectory of emissions out into the future. So you can see we've gone through a period of enormous emissions reduction for everything other than ammonia, which arises predominantly from farming, for reasons that perhaps I won't go into in this talk. And this has been driven by two sets of levers. One is national policy to reduce emissions. So at the moment we're operating under a clean air strategy that was published in 2019. So I think there is hope that there will be a new clean air strategy, certainly for England and Wales, coming in the next year or two. And we also have international levers. So the UK is a signatory to the Gothenburg Protocol and so on, that limits emissions as well. So we've had these two national kind of drivers that have helped drive emissions down. And that's worked very well historically. But as I'll show, we may need to move in the future to sort of more local levers, or more local interventions, or more local ideas around emissions reductions, rather than relying entirely on policy that's set sort of well above our pay grades at the national level. And this really matters actually around emissions, because it's the only part of the air quality problem really that we have under our control. So when you go outside, the amount of air pollution that you breathe is a function of the emissions, the weather, and atmospheric chemistry, and we can't control the weather and we can't control the chemistry. So the only part that policymakers, at whether it's the local or the national level, have under their control is to manage emissions. And the final thing I would say on this is most of the easy wins have been taken. So most of the easy stuff that could be done to improve air quality has already been done. The things that are left are more difficult to do, either cost-wise or behaviour-wise, or in terms of social acceptability. So there is this huge opportunity around decarbonisation and net zero, and there's a very good report from the Royal Society from about 2 or 3 years ago now that tried to look at what the air quality and broadly health impacts would be of decarbonising the UK economy. And it came up with some estimates of broadly whether interventions were going to be positive, neutral, or negative for air pollution, and put some sort of uncertainties on it. And there's an awful lot of information on this, but there are some things that are unequivocal wins. So great to hear about a solar farm going in. If you take out a gas-fired power station and you replace it with a photovoltaic array, that's clearly a win for air quality. But some other things associated with energy we're rather uncertain on. It's not really clear what the air quality impacts of, for example, carbon capture and storage might be. That's a very large chemical process that we don't have much experience of. There are things around transport that definitely look like wins, for example, around electric vehicles. But there are other things around hydrogen engines or biofueled engines which are perhaps not so positive. So if you run an engine, a diesel engine on biofuels, it still generates the same pollutants as running it on diesel, but it might be carbon neutral. So there's a whole load of choices around decarbonisation, where really the job that we have to do is to try to optimise the decisions that we make in order to be sure we get the best possible air quality and health outcomes from those decisions. And sometimes the air quality and health dimension isn't so visible. So the overriding priority is to decarbonise without too much thinking about the mechanism, about how we do that. But the key message, and I've sort of put it in layman's terms in the Royal Survey, is basically don't burn stuff if you can. That might not always be possible, and I suspect we will burn quite a lot of stuff in the future. If you watched any news over the last few days, we're going to clearly burn a lot of sustainable aviation fuel. So that will generate air pollution. So we need to do better. So if we're going to burn stuff for net zero, we need to do better than we currently do burning gas or gasoline or diesel. It's a chance to set more stringent requirements. If you rewire the whole of the economy to decarbonise, you can reset the rules. So we're going to reset the rules. Why don't we reset the rules to have more stringent air quality guidelines? And we really have to look out for unintended consequences. And one example of that is improving the energy efficiency of buildings may actually reduce their ventilation rate. So we could be in a very efficient lecture theatre, but if we have poor air exchange or air management, we might be sitting here with a lot of particles and pollution flowing around. So there's a lot to think around the decarbonisation aspects of improving air quality, including around urban infrastructure as well. What are the buildings going to look like? What are the transport systems going to look like? What are businesses going to look like? Have they thought about the air quality impacts of their net zeros? Right, one thing, and I'd say do have quite an association with the Department for Transport, and one thing that we have to be really aware of is not getting too wedded to the things that have worked well for us in the past. And there's been huge problems with pollution from vehicles, enormous problems, particularly in the 90s through the 2000s. But the situation has changed incredibly quickly, or certainly very quickly in the sort of grand scheme of environmental change. And so you can see this is just looking at the emissions of nitrogen oxides from 3 classes of vehicle. And you can see emissions have fallen really very dramatically for all classes, not necessarily on the same trajectories, but they've fallen pretty rapidly. A lot of that is down to improved regulation of emissions controls and them actually working properly in the real world. But the point of that graph is that we've thought up and introduced lots of pretty effective urban interventions around clean air, which have worked. But you can see as we go into the future, the impact from transport is diminishing very rapidly. So an urban intervention that we've really clung on to as being an effective way of improving air quality in cities and has worked in the past will do less and less for us in the future because that particular sector of the economy actually is a lot cleaner than it was. And this is really hard. People have invested huge amounts of time, money, political capital and so on into things like clean air zones. And they have been effective, but they will only deliver perhaps smaller incremental improvements in the future. So we've got to be prepared to move on from things that have worked in the past and accept we've got to do different stuff in the future. I put these slides together actually about a week or so ago, so I didn't realise it would be topical, but airports, right, there's an example of something that we never really thought about in terms of air pollution, because the roads were such an enormous source of nitrogen oxides that we really thought of airports as a problem for air quality because you drove to them. But as road transport's emissions have diminished, you don't have to be a geographer to spot where the airports are on that map. And this is from 2022, and every year that goes by, the bright colours of the airports as sources of air pollution goes up and the roads goes down. So some sources that we really haven't thought about much in terms of urban air quality management are likely to grow in significance as we begin to get as the road transport component begins to disappear away. And the other component of urban planning, I think, that's becoming really important is how we heat homes. So this is for central London, which is a slightly unusual location, but nonetheless it's an example of where we're going. We're at 2025 now, and we have the ULEZ in central London managing emissions from vehicles, and that's largely focusing around nitrogen oxides. But actually in central London, most of the nitrogen oxides now come from buildings, because we've denoxed our buildings far less than we've denoxed our transport. So most people's association with improving air quality in London is what do you do about transport, or what do you specifically do about road transport? But we may need to rethink how we communicate the problem now, because in 2030, rather little NOx is going to come from road transport in central London, but we're going to be left with a lot of legacy gas boilers in offices and universities and hospitals and private buildings. So again, to me, it's another example of how we can't be too wedded to our interventions of the past that worked, because the problem keeps shifting around. And to me, it's an argument around decarbonising the heating of buildings that perhaps we're not talking enough about. That if you decarbonise a building and put a heat pump in, good to hear that Pro-Vice-Chancellors have the money to do that, we're going to get some air quality benefits as well. And it may be that if people are not convinced about the decarbonisation argument with heat pumps, they might be convinced around the air quality arguments. And particle pollution is another one where we may need to slightly rethink our approaches. Particles are much longer lived in the atmosphere than nitrogen dioxide, and so we don't control as much of the particle pollution in our cities as perhaps we used to. And these are some estimates of how much of that particle pollution, particularly for the PM2.5 fraction, is really under our control, particularly under urban control. And you can see that the fraction, if you look at the red bar, is quite small now. And in fact, our particulate pollution that we breathe in is probably now better thought of as a kind of transboundary international pollutant. And so most of our mindsets around air pollution is it's something that you can manage locally. You might blame the local mayor for, or you might write a letter to your local councillor. But actually over time, the amount that cities directly have under their control for PM2.5 is shrinking quite a lot. So we may need to reframe how we describe the solutions to PM2.5 to make them much more national and international, because so much of it is derived from different countries or different regions. And it's going to be very difficult to reach some of the health-based guidelines that exist for PM2.5 because so much of it comes from other countries or comes from other sources. So we are going to have a bit of a mismatch here between what the health guidance might say versus what is going to be practical to deliver. So just towards the end, I'm getting towards the end, I want to just describe that we may also need to think a little bit more, and this is where more specific urban and city level interventions come in, which is a rather more targeted approach to managing air quality. And in the past, we've done most of our management top-down, which is that government has set regulation, and it's a kind of idea that you manage everything from the centre, and it's a rising tides lift all boats. So we kind of get some regulation that reduces emissions, say, from a vehicle, and we'll all get some sort of benefit because all vehicles will improve. And that has worked extremely well. But it doesn't do very much to unwind some things associated with structural disparities in where air pollution is located. And there's probably a role for urban infrastructure to be more targeted, to look at where problems are specifically and target interventions where there are disparities or inequalities in how pollution is distributed and who is affected. And there is a report, which I'm afraid still isn't published, but we're trying very hard to get this released, on the disparities associated with UK air pollutant exposure. And we do have an issue in the UK around a very uneven distribution of pollution, part of it driven simply by geography. If you live in the southeast, you're very close to Europe, it's high population density, it's drier, it's less windy, it's less wet. They drive the red colours towards the southwest. If you live in northern Scotland, not much industry, not much population, and so on. So we do have a disparity in exposure that's driven by sheer geography and transboundary association, but we do have some very substantial disparities in pollution depending on people's demographic status and depending on their ethnicity. And it's quite a loose association between the emissions in your neighbourhood and your concentrations that you're experiencing, but there is an association nonetheless. And when you dig into the details, what we discover is that the more deprived you are, so if you're in IMD, that's the indices of multiple deprivation, if you're in IMD 1, so you're in the most deprived decile in the UK, this is for nitrogen oxides, but it's the same picture for PM2.5, you'll probably have twice as many emissions in terms of kilograms per year in your neighbourhood compared to somebody who's in IMD 10, who is in the least deprived. And this isn't just down to transport. It's often described as a transport phenomenon. Actually, it isn't. It's driven by transport, but it's also driven by heating. It's also driven by proximity to industry and so on. So lots of different sectors contribute to that disparity. So as a society, we have located our emissions in a way that has associated them with some of the most deprived. So can we do structural things in cities to help unwind some of this long-term embedding of pollution into particular locations with particular communities? And it's also very stark in the UK if you look at how particular ethnicities are exposed to emissions. It's quite a complicated graph, this one, but we have deprivation on the bottom, on the x-axis, so the most deprived on average IMD 3 on that side and the less deprived IMD 6 on this side. And if everybody was equal, the trend in disparity, the spend in emissions and deprivation would follow the pink line. But if your group is above the pink line, what it means is that your particular group receives more emissions in its neighbourhood than a matched white British community of the same level of deprivation. So if you match for deprivation and then do an analysis by ethnicity, what you discover is minoritized ethnicity groups in the UK, when you correct for deprivation, almost always receive more pollution emissions in their neighbourhoods than a matched white British group would. So there's a lot of detail and a lot of structural difference in where pollution occurs. And this is where I think the next kind of frontier is for air pollution, is not relying entirely on top-down central government regulation, for example, on what comes out of an exhaust pipe, but more bespoke, targeted urban action that says we clearly have a problem associated with particular areas and particular communities in this town or in this city. And so this phenomena isn't limited simply to the big cities in the UK. It occurs also in towns and some rural areas as well. So I got here a couple of questions which I think would be good for Reclaim and other urban infrastructure investments to think about, which is how much does the intervention that you're proposing or working on, how much does it reduce emissions? That's the first thing. How much does it improve air quality? They're quite technical aspects related to the emissions from the process. But who in society pays for that piece of infrastructure and who gets the benefit of the intervention? And I think perhaps we don't ask that question enough at the moment, is who is going to be the beneficiary here? And can we make the beneficiaries some of these groups who at the moment seem to receive more than their fair share of the dose of pollution that remains? So just to summarise, there's been massive success in reducing pollution in the UK and reducing emissions, and we should celebrate that, and we should say successive governments over 50 years have done a good job in taking this seriously and reducing the impacts. So that's really good. We have more to do, and we have to deal with this challenge of diminishing returns. And we have to deal with a lot of diffuse sources that are often quite close to home, actually often involve our homes. So we've got a much more active role to play in this. The urban future is clearly much more than just battery electric cars. So we're going to need to argue the case that net zero infrastructure is also intrinsically clean. So we don't simply decarbonise, but we do it in a way that's clean for public health as well. We're going to think a lot broader than road transport. That will not do the job for us in the future. We're going to need to think about difficult things like heating and non-road transport and industry and airports and homes and cooking and restaurants, and the list goes on. And we really need to get to grips with addressing the disparities of where emissions occur and why different communities seem to be exposed to far greater amounts than others. And the final thing, which I think is really important to this group, is around effectiveness and value for money. And this is one question that through Defra and the Department of Transport we're asked all the time, which is, where is the scientific evidence of effectiveness? If we have £1 million to spend, where's the best place to spend the £1 million? And clearly money is tight at the moment. And yeah, finally, just to reiterate my point that it's really great if you can demonstrate not only what the improvement in air quality is, but broadly who is paying and who is benefiting. So thank you very much.